Supra presents. Supra distributed VRF. In the world of Web3, unpredictable, unbiased, publicly verifiable randomness is needed. Randomness in computing. Randomness is one of the most important factors for achieving security in computing systems. In particular, randomness is an essential part of the design of any public key cryptography scheme. What is a good random number? Unpredictable, no one can compute them ahead of time. Unbiasable, good random numbers are not subject to biases that would make specific numbers more likely to appear than others. Publicly verifiable, anyone can verify whether the number is computed correctly. An ideal source of randomness can be modeled as a function. This type of function starts with the input of a number and returns a number that has all of the above properties. Verifiable random functions, VRFs, are cryptographic objects that, provided a given input and a randomly chosen secret key, produce outputs that are as good as random. Technically, called pseudorandom. SK secret key. All the above properties are satisfied for all practical, technically, called probabilistic polynomial time purposes, as long as the key is kept secret. However, when the key becomes known, the function becomes predictable, and thus it no longer produces good randomness. This becomes a single point of failure, because any compromise to that node would lead to a crucial breach of security, as it would render all random numbers predictable. Contrary to our model, centralized VRF computation relies upon one single node to store the secret key. In contrast to a centralized VRF, no single node has access to the entire secret key in our dVRF framework, an extension of a VRF with more robust properties of decentralization. The secret key is shared between a number, say n, of nodes. The Supra design choice demonstrably satisfies all of these properties. dVRF should be consistent, robust, available, and strongly pseudorandom. In dVRF designs, Supra use protocol GLOW, which is heavily based on BLS threshold signatures. Output private dVRF. The novel notion of output private dVRF, or PVRF. Based on GLOW, we propose a new design that satisfies our PVRF definition. While the PVRF design requires a few additional changes, this additional feature comes with virtually no additional overhead. Let's take a closer look at optimized dVRF framework. In conclusion, we will say, Supra's VRF service provides a fast, reliable, decentralized VRF service with novel functionality and optimization techniques. We deploy a state-of-the-art distributed VRF primitive, namely GLOW, which is provably more secure than the existing deployments, due to strong pseudorandomness. It is also significantly more efficient due to our use of ZKPs. This means that Supra can provide the first private VRF service without adding any significant overhead. Hurry up to join us and build together.